Hey everyone, today we are going to dig into something that's literally right under our feet, but honestly, it's something we don't think about nearly enough. We're talking about soil, and I promise by the end of this, you are never going to look at it as just dirt, ever again. So let me ask you, when you hear the word soil, what's the first thing that pops into your head? For a lot of us, right, it's just brown stuff, something you wash off your shoes. But what if I told you that's kind of like looking at a forest and only seeing firewood? Because the truth is, soil is this incredible living universe in miniature. It's a whole world down there, just buzzing with life. It's the biological engine that really powers almost all life on land. So come on, let's get our hands dirty and figure out what makes this ecosystem tick. So here's our game plan. First, we'll look at how soil is even born from solid rock. Then, we're going to take a journey down through its different layers. After that, we'll check out its recipe, what it's made of, and its chemistry. Before, finally, we talk about how we can protect this amazing resource. Okay, so let's start at the very, very beginning. Where does soil actually come from? I mean, it doesn't just appear out of nowhere. It has to be created. At its most basic, soil is this wild mix. You've got your inorganic stuff, that's the tiny bits of weathered rock. Then you've got your organic matter, which comes from plants and animals that have decayed. Then you mix in some water, some air, and a whole bustling city of tiny living things like bacteria and fungi. It's how all these ingredients come together that really tells the story. Now, what's just mind-blowing is how long this all takes. This isn't something that happens over a weekend. It starts with solid rock, the bedrock. Over, and I mean over, huge stretches of time. Things like wind and rain slowly grind that rock down into tiny particles. Then, as life happens, plants grow, animals live and die, their organic bits mix in. And here's the kicker. This process takes hundreds, sometimes thousands of years. That's what makes good soil so incredibly precious. It's basically a non-renewable resource on a human timescale. Okay, so now we know how it's made. Let's take a little trip downwards. If you could just take a big slice out of the ground, like a piece of cake, you wouldn't just see one uniform brown layer. Nope, you'd see these really distinct layers, and we call them horizons. Let's build it from the bottom up, shall we? Way down at the bottom, you've got the C horizon. This is pretty much just broken up bedrock. Moving up, you hit the B horizon, or the subsoil. This is where a lot of minerals that wash down from above end up collecting. Then we get to the star of the show, the A horizon. This is the topsoil. It's that dark, rich, crumbly stuff where most of the action happens. And sitting right on top is the O horizon, the organic layer of leaves and twigs that acts like a protective blanket. So what makes that topsoil, that A horizon, so special? Well, a huge part of it is this stuff called humus. And no, not the kind you dip your pita bread in. This humus is what's left after plants and animals have completely decomposed. Think of it as a super sponge for water and a pantry packed with nutrients for plants. It's also one of the planet's most important places for storing carbon, locking it safely in the ground for ages. All right, so we've journeyed through the layers. Now let's talk about what those layers are actually made of. We're going to get a feel for their texture, which all comes down to the size of the little mineral bits inside them. And this right here is pretty much the perfect recipe. It's for a type of soil called loam, which is just fantastic for growing stuff. You see, it's got this nice balanced mix, about 40% sand, 40% silt, and just 20% clay. That balance gives it the best of all worlds. So why does that mix matter so much? Well, think about the extremes. Sandy soil has big particles, so water just zips right through it. That's great for aeration, but it dries out super fast. Clay soil is the total opposite. The particles are tiny, so they hold on to water like crazy, but there's not much room for air, and things can get waterlogged real quick. Loam, it gives you that perfect middle ground. So we've got the physical side down, but there's this whole other invisible but absolutely crucial factor at play: soil chemistry. This is what determines what nutrients are actually on the menu for a plant to eat. And the key player here is something called pH. The easiest way to think about pH is as a gatekeeper for nutrients. It's a scale that measures how acidic or alkaline the soil is, and it literally controls which minerals can dissolve in water so that plant roots can suck them up. So if the pH is wrong, the nutrients could be right there in the soil, but they're basically locked away, and the plant can't get to them. You can really see that effect here. If soil is too acidic, some minerals can actually become toxic, while other important ones are unavailable. If it's too alkaline, other key nutrients like iron get locked up. See that spot right in the middle? That's the sweet spot, where the widest range of nutrients are available for the plant to use. And for most plants, that sweet spot is a pH somewhere between 6 and 8. If you're going to remember one number from this section, that's it. It's the range where plants can access the biggest buffet of nutrients they need to grow strong and healthy. All right, so we've established that soil is precious, it's complex, and it takes forever to form. That means we have a big responsibility to protect it. So let's look at the biggest threat it's facing and, more importantly, what we can do about it. And that number one threat is erosion. Wind and water are constantly trying to just pick up and carry away that priceless topsoil, that A horizon we talked about, the one with all the good stuff. And when that's gone, the land's ability to grow food just plummets. So how do we fight back? Well, one really elegant solution is called contour farming. Instead of plowing straight up and down a hill, which basically creates little highways for water to rush down, farmers plow along the natural curves of the land. Each one of those rows acts like a tiny dam, slowing the water down and giving it time to soak in. Now, for really steep hills, you can take that idea to the next level with terracing. This is where you literally build broad, level steps into the hillside. It's a technique that's been used for thousands of years, and it completely transforms a steep, erosion-prone slope into a series of flat, productive gardens. And what about wind? To fight wind erosion, we use wind breaks. It's exactly what it sounds like. Just like a fence protects your yard from the wind, planting rows of trees along the edges of fields slows the wind way down right at ground level. This keeps all that valuable topsoil from just blowing away to the next county. So we have covered a lot of ground today. Yeah, pun intended. From the birth of soil all the way to how we can protect it. Let's just do a quick recap of the most important ideas you should walk away with. Okay, try to lock these 4 things in. First, soil is not dirt. It's a living ecosystem and it forms incredibly slowly. Second, topsoil, that A horizon, is the key to fertility, all thanks to that amazing stuff called humus. Third, the texture, that mix of sand, silt, and clay, is what dictates how the soil holds water and air. And finally, keeping our soil healthy means we have to use smart farming practices to stop erosion in its tracks. So I'll leave you with a question to think about. Now that you know that the ground beneath you is alive and precious, what's just one thing, one small change in your community, in your own backyard, or even in the choices you make at the store that could help protect the living soil we all depend on? Thanks so much for joining me today.